Good morning to all. In today's class, I will explain garbage collection. So garbage collection is very important in Java. Okay, one of the most important concepts in Java is garbage collection. So try to understand garbage collection carefully. It's very important for interview point of view and for exam point of view also. Okay, so here in garbage collection, we will discuss these 4 topics. That is introduction about garbage collection. Next, how to make objects eligible for garbage collection. Next, methods to request JVM, that is Java Virtual Machine, to run garbage collector. Next, finalization, means in this we use finalize method. So these are the 4 important concepts which we will discuss in garbage collection. Introduction, how to make objects available for garbage collection, and methods to request JVM to run garbage collector, and finalize method. These are the 4 important topics we have in garbage collection. Now we will see first introduction part. Now we will see what is the difference between C++ and Java, okay, with respect to this concept. Okay. So if you see the introduction part, if you see the C++ language, the programmer, here programmer it is. So programmer is responsible for both creation and destruction of objects. Okay. So here the programmer is responsible for both creation and destruction of objects in case of C++. But usually the programmer is taking very much care while creating the objects and neglecting the destruction of objects. So due to this negligence, at certain point of time, the memory may not be available for creation of new objects. See, you know, memory is limited now always. We won't get infinite memory, only limited memory. So due to this problem, means due to this negligence, the memory may not be available for creation of new objects after certain point of time. Therefore, there may be a maximum chance of failing the application due to memory problem. This is in case of C++, because in C++ the programmer is responsible for both creation and destruction of objects. That's why usually the programmer will concentrate more on creation of objects and he will not concentrate on destruction of objects. Due to that, this memory may not be available, and at certain point of time the application may fail due to memory problem. This is the drawback of C++ because the programmer is responsible for both creation and destruction of objects. Now when you take Java, in Java the programmer is only responsible for creation of objects. This is important concept in Java. So here the programmer is responsible only for creation of objects and he is not responsible for destruction of objects. So when he is not responsible for destruction of objects, who will destroy the memory allocated for the objects? Somebody should be there now to destroy the objects. So in case of Java, okay, the garbage collection or garbage collector, okay, it will destroy the objects memory. Okay, the programmer need not worry about the objects destruction. Only he is responsible for creation of objects. That's why here some people developed some people provided an assistant called garbage collector, which is always running in the background. Okay, this is the new concept they have added in Java. So due to this garbage collector, there may be a less chance of failing the Java application, and hence Java is considered as robust language. So one of the features of Java is robust. Why Java is called robust is the programmer need not worry about the destruction of objects, and some people provided an assistant called garbage collector, okay, which will destroy the useless objects. So this is the concept in Java, that is garbage collection. Okay, here this is very important. Because of this garbage collection only, Java is considered as robust language. Okay. In C++, this facility is not there. The programmer is creating the objects and destructing the objects. Here in C++, we have 2 concepts constructors and destructors. So constructors are used to create the objects and destructors are used to destroy the objects. Destroy the objects is nothing but the memory allocated for the objects is released. That is nothing but destruction of the objects. So in C++ we have two concepts, constructors and destructors. But whereas in Java we have only one concept, that is constructors. So you know now we have not studied destructors. Okay, so in Java we have only one concept, that is constructors. So constructors' main purpose is to create the objects. Who will destroy the objects in Java? Okay, that is the answer for this question is garbage collector. Okay, or with garbage collection we can destroy the objects, or we can destroy the memory allocated for the objects. Destroying the objects is nothing but releasing the memory allocated for the objects. It is nothing but destroying the objects. So in Java, programmer is only responsible for creation of objects, and with garbage collection, the garbage collector will destroy the memory allocated for the objects. So garbage collector will take care of the destruction of objects. Programmer need not worry about the destruction of objects in case of Java. So this is the introduction about garbage collection in Java. It is there in Java only. It is not there in C++. So in Java we have only constructors which are used to create the objects, and with garbage collection the objects are destroyed. Okay. So this is the introduction about garbage collection. Next, you know how to create objects now. Once you define the student class, how we are creating objects? Student S1 is equal to new student. Okay, so student S1 is equal to new student. In that the right hand side part is nothing but object. With the new operator, memory is allocated for the student class variables. So you know how do we create the objects? Student S1 is equal to new student. New student is nothing but object, and the S1 is the reference variable which holds the address of that object. Already we know this, no? Now here, coming to the objects, we have two types of objects. What are they? Useful objects and useless objects. So what is the difference between useful objects and useless objects is, if the reference variable is there for that object, then that object is called useful object, because with that reference variable we can access the members of the object. Okay. Next, what is useless object? If there is no reference variable for an object, then that object is called useless object. Why? Because when there is no reference variable to that object, how can we access the members of that object? We can't access the members of the object without reference variable. That's why reference variable must be there to refer that object. Reference variable is nothing but which holds the address of the object. Through reference variable only we will access the members of the object. That's why the difference between useful objects and useless objects is, when there is a reference variable to an object, then that object is called useful object. In this example, student S1 is equal to new student. Means S1 is referring this object. Through this reference variable I can access the members of the object. Okay, that is this. If you see the statement in this object is right hand side is object. No, this object is called useful object. Now next, what is the definition of useless object? When there is no reference variable to an object, then that object is called useless object. Now in this statement, after this statement I will write S1 is equal to null. Previously S1 holds the address of this object, no? But after that what I will do is, I will assign null to this S1, means S1 is equal to null. Means S1 is holding null, means S1 is not holding the address of this object. Means there is no reference variable for this object. Means that object is called useless object. Okay. Now understand the difference between useful object and useless object. If reference variable is there for an object, that is called useful object. When there is no reference variable for an object, then that is called useless object. And now in garbage collection, we will discuss using useless objects only. Garbage collector will destroy only useless objects. It will not destroy useful objects. Okay, the role of garbage collector is to destroy useless objects. That's why concentrate on useless objects in garbage collection. Okay, useless object means when there is no reference variable for an object, then that object is called useless object. Okay, in garbage collection we will discuss with respect to useless objects. Next, after understanding the difference between useful objects and useless objects, see here I will read this one. Garbage collector will destroy only useless objects. Okay. Next, JVM will invoke the garbage collector. Then garbage collector will enter into the heap memory to destroy the useless objects. Already explained. Inside the heap memory, objects are stored. Okay. Already I explained, no? Memory is divided into three parts: stack memory, heap memory, and method area. Inside the heap memory, the memory is allocated for the objects. That's why who will invoke the garbage collector? Now the question is, who will invoke the garbage collector? That is, the answer for that question is JVM will invoke the garbage collector. Okay. Then garbage collector will enter into the heap memory to destroy the useless objects. So these two lines are very, very important. Programmer cannot invoke garbage collector directly. Okay. JVM has to invoke the garbage collector. Okay. The programmer cannot invoke garbage collector. JVM will only invoke the garbage collector. Then garbage collector will enter into the heap memory and it will destroy the useless objects which are there inside the heap memory. This concept is important. Next. So after entering the garbage collector into the heap memory, okay, we don't know how many objects are destroyed by the garbage collector when it is entered into the heap memory. Means when garbage collector enters into the heap memory, okay, we don't know how many objects in the heap, how many useless objects in the heap memory are destroyed by the garbage collector, because it will not destroy all the useless objects. It will destroy only some objects. That's why we don't know how many useless objects are destroyed by the garbage collector when it enters into the heap memory. So this para is very, very important. Okay. Next, the programmer cannot invoke garbage collector, but the programmer can request the JVM to run the garbage collector. This is there. Programmer cannot invoke directly garbage collector, but through JVM we can make a request to run the garbage collector. That's why here the sequence. So in between the programmer and garbage collector, JVM is must, because programmer cannot invoke garbage collector directly. Through JVM only programmer can invoke the garbage collector. That's why programmer will make a request to JVM to run the garbage collector. So this sequence is important. Next, so with this, you know the introduction of garbage collection. Okay. Next, second is how to make objects eligible for garbage collection. Okay. Second one this is. So even though the programmer is not responsible for destruction of useless objects, already in the last para I explained the programmer cannot invoke garbage collector, no. But even though the programmer is not responsible for destruction of objects, already explained in the introduction, beginning of the introduction part, in Java the programmer is not responsible for destruction of useless objects. Only he is responsible for creation of the objects. Okay. But even though the programmer is not responsible for destruction of useless objects, but it is a good programming practice to make an object eligible for garbage collection when it is no longer required. Suppose if you don't want to use one object in the rest of the program, okay, only in some part of the program I am using that object. After that I don't want to use that object in the remaining part of the program. In that case, I can make the object eligible for garbage collection. Okay, so how do we make the object eligible for garbage collection? I will explain the concept. Okay. Now here, see this small program, already you know this program, class student. Inside this program, the instance variables are roll number and marks, and inside the main method I have created two objects for the student class. Student S1 is equal to new student, so S1 points to the one object and S2 points to another object. Only addresses of the objects are stored in the reference variables S1 and S2. S1 and S2 are called reference variables. This is object, this is object. Already explained, when the statement is getting executed, from this statement it will go to the student constructor, okay, and verifies for the constructor. But here there is no constructor written by the programmer. That's why in this case, default constructor, that is compiler generated constructor, is executed, which will allocate default values for the instance variables roll number and marks. That's why if you observe the values for roll number and marks inside each object is 0, 0.0, because here default constructor is executed, which will assign default values based on the data type for roll number and marks. Already I explained in depth about constructors. Okay, please revise once. Next, in the memory, so already we know now we have two types of memory here, stack memory and heap memory. Inside the heap memory, objects are stored, and inside the stack memory, okay, reference variables are stored. Okay, already explained this one. Reference variables are stored inside the stack memory and objects are stored inside the heap memory. Now if you take this program, here S1 and S2 both are useful objects. Why both are useful? Why these two objects are useful objects? Means these two objects are having reference variables S1 and S2. With S1 I can access the members of this object, and with S2 I can access the members of this object using S1 dot roll number, S1 dot marks, S2 dot roll number, S2 dot marks. That's why these two objects are called useful objects. Okay, this program already you know. Now I will explain the next concept, that is so how do we make the objects eligible for garbage collection? Okay, so by assigning null to the reference variable, we can make the objects eligible for garbage collection. Remember this one. If it is no longer required, if you don't want to use that object in the rest of the program, assign null to that reference variable, automatically that object will become useless objects which is eligible for garbage collection. Okay, now I will explain here. So here class student, this what you know, inside the main method I have created two objects like in the previous program. Here also I have created two objects. No? Next, after that what I am doing is, so I have created two objects for two students with reference variables S1 and S2. So here in this part only I have used this object. After that, this is the end of the main method. No? After that I am not using that object, first object that is referred by S1 in the rest of this program. Then in this part only I have used the first object S1. So after that I don't want to use this first object. Then what I will do is, I will assign null to that reference variable, means S1 is equal to null. When you assign null to S1 means the link is removed. Now this link is destroyed. Now there is no link in this one, S1 is this one. No? Now this link is removed. Means S1 is assigned null, means it is not storing the address of the object. No, that is, it is not storing 100. 100 is the address of this object. So when you assign null to S1, this link is getting destroyed. What does it mean? When there is no reference variable for any object, this object is eligible for garbage collection. Put cross mark here when you write the notes. Means this object is called useless object. Already explained, only garbage collector will destroy useless objects. So here now the question is, after assigning null to S1, and now here how many objects are eligible for garbage collection after this statement is getting executed? You can easily say only one object is eligible for garbage collection because it is the useless object. Okay. Next, after some point of time, I don't want to use the second object also. I have used, and in the rest of the program I don't want to use the second object. Then what I will do is I will assign null to S2. Then in that case what will happen? This 200 is replaced with null, means this link is getting removed. Then there is no reference variable for this object also, means this object is called useless objects. Now after execution of this statement, the question is how many objects are eligible for garbage collection, means 2 objects. Because for S1 there is no reference variable, and for S2 also there is no reference variable. So here if you see the question, how many objects are eligible for garbage collection, means 2. Okay, like that here you may get the questions in garbage collection. So after the execution of this statement, how many objects are eligible for garbage collection, means only 1. But after execution of this statement, how many objects are eligible for garbage collection, means 2. Okay. Now see here, what is the second concept? We can make the objects eligible for garbage collection. Okay, if they are no longer required. How do we make the objects eligible for garbage collection when they are no longer required? Means by assigning null to the reference variables. Okay, so this is the concept. Next, third concept. So first introduction completed. Next, how do we make the objects eligible for garbage collection completed? Third concept is methods to request JVM to run garbage collector. So already explained, the programmer cannot invoke garbage collector directly, but the programmer can send a request to JVM to run garbage collector programmatically. Through program, we can request JVM to run garbage collector. These 2 lines are very, very important. The programmer cannot invoke garbage collector directly, but the programmer can send a request to JVM to run garbage collector programmatically. So how do we request JVM to run garbage collector programmatically? There are 2 ways to request JVM to run garbage collector. First one is using system class. Second one is using runtime class. Okay, there are 2 ways to request JVM to run garbage collector programmatically. First one is using system class. Second one is using runtime class. Okay, first I will explain how do we request JVM to run garbage collector using system class. Okay, next again, system is a predefined class. Inside the system class we have one method, that is garbage collector, and it is static method. Okay, inside system class we have one predefined method GC, okay, which is a static method. So this is the system class definition. It is not there. System.gc is not there. So remember, inside system class we have one static method garbage collector. Okay, GC of parenthesis. GC is the name of the method, and it is not taking any parameters, and return type is void, and it is static method. Okay, so system is a predefined class which is having one static method garbage collector GC. GC is the static method inside system class. This statement is not there here. Strike off this one. Next, so how do we access the static method of system class inside our class? Means our class is different now. So how do we access the static method of system class in another class that is outside the class? Is class name dot method name, means system.gc. Using system.gc we can access the GC method of system class in our class. Our class is different now, means outside system class means our class. So outside the system class we can write system.gc to access the GC method of system class. Because it is a static method, we can use class name dot method name. That's why system.gc, because it is a static method. So out in our class we can use system.gc to access GC method of static class. Okay, that's why system.gc is used. Since GC is a static, here it is method. Since GC is a static method. Okay. Now I will explain one program that with GC method of system class. Okay. Now This is easy only. So this is class student. Here roll number and marks are instance variables, and inside the main method I have created two objects. Next, after that, in the previous program, I am making the first object eligible for garbage collection by assigning null to S1. After some point of time, I am making the second object is also eligible for garbage collection by assigning null to S2. So at this point, means after this statement, two objects are eligible for garbage collection. Means inside the heap memory, we have two objects with no reference variables. Means two objects are useless objects. Means they are eligible for garbage collection. Okay. Next, after that, I am sending a request to JVM. Okay, to run garbage collector to destroy the useless objects. That's why what I will do is I will use GC method of system class for sending the request to JVM, that is system.gc. Okay, means with this statement I am requesting JVM to run garbage collector. When we request JVM to run garbage collector, we don't know whether our request is accepted by JVM or not, but we can send a request like this. Okay, and suppose if your request is accepted by JVM with this statement, then JVM sends garbage collector, okay, to heap memory. Then it will destroy the useless objects, but we don't know how many objects are destroyed by the garbage collector when it enters into the heap memory. Okay, so system.gc is used for sending a request to JVM to run garbage collector. Okay, next, that is the first one. No, next, second one is using runtime class. So there are two ways to request JVM to run garbage collector. First is using system class. Inside system class, one static method is there, that is GC. Okay, using GC method of the static class, we can send a request to JVM to run garbage collector. That is the first program. Next, what is the second way is using the runtime class. Next, runtime class is a predefined class and it is a singleton class. What is the importance of singleton classes is, for singleton classes, we can't create objects with new operator like normal classes. Student is normal class, no. We can create object for student class with new operator, no. Student S1 is equal to new student. But for singleton classes, we can't create objects with new operator. Okay, but without creating objects with new operator, how do we access the members of the singleton class now? Already explained. Okay, we must create objects to access the members of the class. But here for singleton classes, we can't create objects with new operator. But the other way is using this is error, no? Runtime R1 is equal to new runtime. So because runtime is a singleton class, we can't create object for runtime class with new operators. So if you write like this in your program, you will get compiler error because syntactically it is wrong because it is a singleton class. Next, how do we create object for runtime class is using factory method. So inside the runtime class, we have one method that is getRuntime, which is a static method of runtime class and return runtime class object. Okay, so with this method, we can create the objects for runtime class. So how do I create? Runtime R is equal to runtime dot get runtime. Get runtime is a factory method and which is a static method. So static method of this runtime class can be accessed with the class name. That's why class name dot method name, because it is a static method. Okay, static methods of one class can be accessed outside the class using class name dot method name. Already explained static variables in the same way static methods. So static methods of one class can be accessed outside the class with class name dot method name. That's why here already explained get runtime is a static method inside runtime class. So how do I access get runtime of, which is a static method of runtime class, is using class name dot method name. That's why runtime dot get runtime. So what is the return type of get runtime is, it returns runtime class object. That's why here with this runtime class object is returned and the address of that runtime class object is stored in this variable R1. So with this we can't create, no. Actually this is the object creation syntax, no, new runtime. But for Singleton classes we can't use this syntax. So instead of using this syntax for Singleton classes, we have to use factory methods. That is runtime dot get runtime. This get runtime will return the runtime class object. Object means address is there, no. That address is stored in this reference variable, or like that we can create the objects for Singleton class. Next after that, so this is the object creation for Singleton class runtime. Okay. Next, this is the predefined runtime class. So class runtime. Okay. So inside that this runtime we have 4 methods. First method is get runtime, which is a factory method, and it is a static method. And the return type of this get runtime is runtime class object. It returns object. Okay, which object? Runtime class object. Next after that, GC is a method, but GC method of system class is static method, but GC method of runtime class is non-static method. Remember, non-static methods can be accessed with only reference variables. There is no other alternate. So this is a GC is a non-static method inside runtime class, which is a static method inside the system class. You remember that, okay? Next after that, 2 more methods are there, total memory and free memory. The return type of these 2 functions are int. Okay. Now with these 4 methods, I will write one program. Now what is the total memory means? To find the size of the heap. Heap is the memory, no. Inside heap we are storing objects, no. To know the size of the heap, we can use total memory. To know the how much memory is available freely, we can use free memory method. Both are non-static methods. Means non-static methods of one class can be accessed outside the class using reference variable only. Okay. Now the free memory is used to find the free memory available in heap. Next, with these 4 methods, what are the 4 methods of runtime class? Get runtime is one method, GC is another method, total memory is the 3rd method, free memory is the 4th method. With these 4 methods of runtime class, I will explain one program. This program is also used for requesting JVM to run garbage collector. Means programmer is sending a request to JVM to run garbage collector, because programmer cannot invoke this garbage collector directly. Through JVM only, programmer has to invoke garbage collector. So this is the program for making a request to JVM to run garbage collector using runtime class. Okay. Now class runtime demo inside this main method. And now this is the runtime class object creation, already explained. Runtime r is equal to runtime dot get runtime. After that, with this reference variable, I am using the other 3 methods of that runtime class. They are GC, total memory, and free memory. After creation of the runtime class object, we can access the members of that class with this reference variable. That's why with R, I can access total memory, free memory, and GC. 3 methods are there now. Actually 4 I have explained, but here I have used one method, get runtime, that is used for creation of the object for runtime class. Okay. The remaining 4 methods are GC, total memory, and free memory. So after creation of that runtime class object, we can access the remaining 3 methods with this reference variable. Okay. Concept is same in all programs. Now system.out.println r.total memory. Now it will give you how many bytes. The return type of this is integer, no? So it will return how many bytes how many bytes are there in the heap memory, or the size of the total size of the heap memory. That is 529 bytes. Let us take. Okay. Next, system.out.println r.free memory. Inside the heap memory already you know, no? Inside the heap memory, objects are stored, no? Means in some part objects are stored and the remaining part is free, no? Now it will show you how much free memory is available inside the heap after storing the objects. That's why total is 521. Free memory means memory available, that is 420. Means 529 minus 420, which is the memory allocated for objects. Okay. So total memory is 529, free memory is 420. Next, After that, what I am doing is I am creating some more objects using this for loop. So for int I is equal to 0, I less than 10,000, I plus plus. Here date d is equal to new date, means date is a predefined class. In calendar concept you will get all these, but in your syllabus it is not there. But you remember date is a predefined class. For that predefined class I am creating object. This is object creation for date class. That's why d stores the address of this date class object. Okay. Next, after that, what I am doing, d is equal to null, means first I am creating one object for a date class with reference variable d. After that I am assigning null to that reference variable, means this date class object is eligible for garbage collection because it is useless object. Means there is no reference variable after this statement, means this date class object is useless object. Okay. Next, after that, this is the first time when I is equal to 0. Again this loop is repeated when I is equal to 1. Again one object is created and I am making that object as useless by assigning null to that reference variable. Okay. Again I is equal to 2. Like that this loop is repeated 10,000 times. Means 10,000 objects are there inside the heap memory which are useless objects because I am assigning null now. That's why inside the heap memory with this for loop 10,000 objects are there. Okay, and those objects are called useless objects. Okay. Now inside the heap memory, okay, we have 10,000 objects which are useless objects. After execution of this for loop, what I am doing is again I am checking the free memory. Okay, available in the heap memory. So r dot free memory. R dot free memory means previous free memory is 420 now. But after this, the 10,000 objects are there in the heap memory now. Means the memory is reduced now. That's why here 390 means 10,000 objects are there in the heap memory. That's why here you will get 390. Okay. After that, see I am making a request to JVM to run garbage collector using this statement, that is r.gc. Okay. GC is a non-static method inside the runtime class. How do we access the non-static methods of one class in another class is using the reference variable. Static method means we can use class name, but non-static method means we must use this reference variable. Okay. That's why r.gc we must write. In case of system class GC method, we have written system.gc because GC is a static method of system class. But here GC is a non-static method of runtime class. That's why non-static methods of one class can be accessed outside the class using reference variable only. That's why r.gc. Okay. This is the statement which we are requesting, or we are sending a request to JVM to run garbage collector. Okay. After that, let us assume that we have sent a request to JVM. No, JVM is accepted our request, and JVM sends garbage collector to heap memory. So I assume that the garbage collector entered into heap memory. Now when it enters into the memory, it will destroy some objects. No, it will not destroy all objects. It will destroy some objects, but we don't know how many objects are destroyed by the garbage collector when it enters into the memory. Because of that reason, system.out.println r.total memory. Again I am taking the total memory. Now see here, if you observe 470. Actually, if it destroys all the objects, you may get nearer to this now. But one more thing is, so garbage collector will not destroy useful objects, because inside the heap memory some objects are useful and some objects are useless. That's why when it enters into the heap memory, it will concentrate only on useless objects and it will not destroy all the useless objects. That's why here you will get 470. Now you won't get 529, because 529 is the total memory. No? Inside that some are useful objects and some are useless objects, and garbage collector will destroy only useless objects. If you execute this program, you can see these values. Okay. So with this third point is completed. Third one is, how do we make a request to JVM to run garbage collector? This is the last concept. Only 4 concepts are there. Okay. What is this one? Finalization. So here in this finalization concept, Here we will use finalize method, F small, finalize method. Okay. What is the very, very important finalize method? So what is the role of this finalize method in garbage collection? I will explain. Okay. Now just before destroying any object, any useless object. Okay. Here this is just before destroying any useless object, the garbage collector invokes the finalize method on that object to perform cleanup activities like closing database connections, closing network connections, closing file streams or files. Okay, understand for the role of finalize method in garbage collection. So already explained in the previous concepts, the role of garbage collector is to destroy the useless objects. No, useless object means when there is no reference variable to that object, it is called useless objects. Okay, now let us assume that inside the heap memory we have some useless objects. What is the role of garbage collector? Garbage collector will destroy the useless objects. But here one point to remember is, it will not destroy the useless object directly. Just before destroying the useless object by the garbage collector, first garbage collector invokes the finalize method on that object. Remember, okay? Just before destroying the useless object, what the garbage collector will do is, garbage collector will invoke the finalize method on that object. Okay? After invoking the finalize method on that object, then only the garbage collector will destroy the object. That is nothing but it will release the memory allocated for that object in the heap memory. Okay, what is the role of finalize object? Finalize method. Again, I am repeating, just before destroying any object by the garbage collector, okay, the garbage collector invokes the finalize method on that object to perform, okay, cleanup activities like closing database connections, closing network connections, and closing file streams. Now, why garbage collector invokes finalize method on that object is to perform. The reason is that to perform cleanup activities. With the example, I will explain this concept. First, understand what is the purpose of finalize method in garbage collection. This is very, very important for exam point of view also. So the purpose of finalize method in garbage collection is, just before destroying the object, the garbage collector will invoke the finalize method on that object to perform the cleanup activities like closing the database connections, or closing network connections, or closing file streams. Okay, I will explain this concept with example program. Then you can understand more clearly. Okay. Next here we will see these points. Explain the difference between finalize method in garbage collection and finally block in exception handling. So in exception handling we will see finally block. Okay. After your first minute I will explain exception handling. So in exception handling we have 5 keywords: try, catch, throw, throws, and finally. This is not final, finally. Okay. So here we have 5 keywords. So the last keyword is finally. But here it is in garbage collection already I discussed finalize method. Okay. Now we should be able to explain the difference between finalize method in garbage collection and finally block in exception handling. Okay. Next, in exception handling we will discuss finally block. Now I will explain finalize method. Finalize method is a predefined method which is available in object class. You know, object is the superclass for all the classes in Java. No? So in that object class we have finalize method. So what is the already explained in our inside object class we have toString method, hash code method. In addition to these two methods, some finalize method is also available in object class. Now what is the syntax of finalize method is protected, void, finalize, throws, throwable. This is exception handling syntax. When we see exception handling, at that time you can understand this. Now don't concentrate on this throws, throwable. Okay, we will concentrate on this. Now finalize is the name of the method, return type is void, and the access specifier is protected and no parameters. So protected, void, finalize, throws, throwable. This is the definition of finalize method. So this is the syntax for finalize method which is available in object class. See, this is class object. Inside that we have this method, finalize method, and this is null implementation. Means nothing is there. Only closing brace, open brace, and closing brace. Okay. Means null implementation. Nothing is there inside that finalize method of object class. Next. To know every class in Java extends object class by default. That's why when you write class test, it extends object class. What is the meaning of extends? Already explained inheritance. So object class methods are inherited to this class test now. Okay. So through this extends, all the members of the object class are inherited to this class test. So finalize method is there in the object class. That's why finalize method is inherited to this class. But already explained overriding concept in inheritance. Suppose if you want to take the object class finalize method, you take. Otherwise, if you are not satisfied with the code of finalize method, you can override that finalize method as you like in your class. That's why if you want to write overriding method, we can write overriding method inside the test class. So overriding finalize method, how do we write it? Same syntax we have to take void finalize. Next, protected, already explained in overriding. The subclass overriding method access for modifier must be greater than or equal to the superclass overridden method. What is the superclass overridden method access specifier? Protected. That's why here, when you want to override the finalize method of the object class in your class, you should take only two access modifiers for this overriding finalize method. They are either protected or public. Because here we can't change this one. This is the predefined method of object class. They have taken here protected. That's why when you override that finalize method, this access specifier must be greater than or equal to. You know the access, this one, no? That is private less than, default less than, protected less than, public. So protected, if it is protected means it must be either protected or public because greater than or equal to. Equal to means protected same. Public is greater than protected. That's why these are the only two access specifiers in the overriding method. Okay. So if you want to override the finalize method of object class, you can override that finalize method in your class. Test is our class, no? Next. Here I want to override the object class finalize method. That's why I am writing this method in my class. So what is the role of this method? Why do we override the finalize method of object class is if you want to do any cleanup activities, okay, in your program, then we must override finalize method. Okay, that's why when you override finalize method of the object class, you must write cleanup code or closing the connections inside this overriding finalize method. Because just before destroying the object, the garbage collector will execute first finalize method of your class if you write, or it will execute finalize method of object class. If you write overriding method, the garbage collector will execute your method. If you won't write, it will execute the finalize method of the object class. That's it. If you don't want to perform any cleanup code, then don't write overriding method. If you want to perform any cleanup closing connections like database connections, network connections, okay, it is must to write finalize method. Otherwise, it is not necessary. It is only optional. Okay, now I will explain how to write the finalize method in our class to perform cleanup activities. Okay, you read this one same. Now, finalize method program. This is. Now here I have our class is test extends object. Here write extends object because every class in Java extends object. So inside object class we have finalize method. Okay. Now I am opening some connections in my class. That is connection C is equal to connection dot get connection. Here connection is also a singleton class. That's why using the factory method I am creating object for this connection. Next, file f is equal to new file. You know files in C language. How do we create a file and how do we open a file? So file f is equal to new file. The of abc.text. This is the syntax in Java language. In Java language also we have files concept. How do we create a file is like this. File f is equal to new file of, this is file name with double quotes. Okay. Next, f dot open. After creation, if you want to open, f dot open use. Okay. Now here, if you take this one, so already these two are instance variables. You can now easily identify. Instance variables means they are within the class and outside any method or block or constructor. That's why I can easily say C and F are instance variables. Okay. Next, after that, I am writing overriding finalize method. So public, here you can use the access modifier either protected or public. If you use private or default, you will get compiler error. Because remember the rule in overriding, the access modifier of the overriding method must be greater than or equal to the access modifier of the overridden method. Because of that rule, okay, we have to use here either protected or public. Both are correct. Here I have written public. So public void finalize. So inside the finalize method, what is the role of this finalize method is to perform cleanup activities. That's why here I have opened two connections using C and F. That's why I want to close them. That's why C dot close, C F dot close. Okay. Now when it enters into the garbage collector enters into the finalize method, first it will print finalize method. After that it will close the connections. Okay. Next, I will explain with diagram. Then you can easily understand. Next, main method. Inside the main method, create the object for test class. After that, T1 is equal to null, means this object is useless object. When we assign null to T1, means eligible for garbage collection. Next, system.gc. You know now system.gc. You know, I am sending a request to JVM to run garbage collector. After that, I have written main method. Okay, this is the main method syntax. I have taken only one class. Now when we execute this program, what will happen, I will explain. So test.java name of the file and compilation is java c test.java, execution is java test. When you execute the program, so understand this diagram. So this is heap memory, this is stack memory. Inside the stack memory, reference variables are stored. First main method is stored inside the stack memory. Okay. Next, you know this one now. We have created an object for test class that is using test T1 is equal to new test. New test is an object for test class. So this is the object which is created inside the heap memory, and the every object has unique address. That address is stored in the reference variable T1, and the reference variables are stored inside the stack memory because this T1 is a part of main method, or T1 is local to main. That's why all the local variables of main method are stored along with main method. That's why main method is stored inside the stack memory. Along with main method, the reference variable T1 is also stored in the stack memory. Now inside the heap memory, objects are stored. Now understand this concept. This is one database connectivity and this is one file. So here we are taking one file and we are opening this file and we are opening one database connectivity. Let us assume like that. Okay. But here inside the object, these are opened. Now you should understand this concept to understand finalize method. Why inside why C and F are stored inside the object? Already explained repeatedly. First, see the instance variables of that class. So inside the class test, we have two instance variables. They are C and F. So instance variables can also be reference variables. No problem in that. Instance variables need not be primitive variables. Instance variables can also be reference variables. That's why here C and F are instance variables. Why? Because these are not declared with static keyword and they are defined or they are declared inside the class and outside the method or constructor or block. So I can easily say C and F are reference variables which are also instance variables. Already explained, inside the object only instance variables of that class will be stored. So I know that C and F are instance variables. That's why inside the test class object only instance variables C and F are stored. Now when C and F are stored, what is C? C is it is opening one database connectivity. Let us assume that, and F is opening one file. C dot F dot open we have written. No? After creating the file, we have written F dot open. That's why F is opening this file. With C, we are opening one database connectivity. But these two connectivities are, these two are opened inside the object now with these two variables. Now that's why we can't close these connections on our own. Why? Because these connections are opened inside the object. Inside the object, when the connections are opened, the programmer cannot close the connections. Already you know one concept. Whenever you open any file, it is your duty to close that file. Okay, whenever you write f dot open, it is your duty to write f dot close. Okay, that's why I can't write, if I write f dot close directly, I cannot close. Why? Because these two files are opened inside the object. Okay, inside the object, if the files are opened, the programmer cannot close those files. But who will close those files which are opened inside the object? Through finalize method, garbage collector will close those files before destroying this object. That is the concept of finalize method. Next, after that, what I am writing here? So here one object is created. Okay, with this object creation, what will happen in the memory? One object is created inside the memory and reference variable is pointing to this object, and inside this object we are opening two database connectivities with C and F. Okay, when you write test T1 is equal to new test, then this is happening. With that one statement, test T1 is equal to new test. T1 is a reference variable which points to this object. Inside that, instance variables of that class are stored C and F, and C is opening one file and F is opening. C is opening database connectivity and F is opening file connectivity. Okay, so this entire thing is happened when that statement is getting executed. That is test T is equal to new test. After that, we will see one by one. Next, this is completed. Next, T1 is equal to null. T1 is equal to null means what? Now this connection is getting destroyed. No? That's why if you observe this one, next figure, T1 is equal to null means there is no connection between these two. So when there is no reference variable for this object, this is called useless object. Previously it was a useful object with this diagram, but after writing T1 is equal to null, this is useless object. Okay, and now useless objects are destroyed by the garbage collector. Now means this object is eligible for garbage collection. No? After that, so T1 is equal to null, completed. Next, after that, what I am writing, system.gc means I am sending a request to JVM to run garbage collector. Let us assume that garbage collector enters into the heap memory. Means JVM accepted our request and JVM sends garbage collector into the heap memory. Let us assume that garbage collector wants to destroy this object. Means it wants to release the memory allocated for this object. Then what is the concept of finalize method? Just before destroying this object by the garbage collector first invokes finalize method on that object. So on this object means it is which class object? Test class object. That's why test class finalize method is executed by the garbage collector. That's why the garbage collector will go to the test class because it is test class object. So it will go to the test class object and it will check for the finalize method whether the programmer has written overriding finalize method or not. But it will find the overriding finalize method. Suppose if the programmer has not written overriding finalize method, then it will execute object class finalize method. Object class finalize method is with null implementation. Just it will go to the finalize method of object class, again come back and then destroy the object. But here we have written finalize method. No, this is called overriding method. First it will check whether programmer has written overriding finalize method in test class or not. When it checks, so here we have written, no, that's why it finds this finalize method, which is overriding finalize method. Now it will execute this. That's why it will print first finalize method. After that, it will close the connection. T dot close and F dot close. Means what will happen? It will close the connections, no? Means now there are no connections. See, means the connection is closed. Previously the file is open, no? Now it is closed. Okay, now both the connections are closed by the garbage collector using finalize method. After that, it will destroy this object. So after execution of the finalize method on this object, it will destroy this useless object. So this is nothing but finalize method. Suppose if you don't want to write any database connections or network connections or file opening the like that in your program, then no need of writing overriding the finalize method. In that case, there is no use. No. Here I have written, I am using file and database connectivities. That's why I am writing overriding finalize method. So it is not necessary to write the overriding finalize method in all the programs. See, previous programs we have not written. No. Why we have not written means I am not taking any database connectivity or network connectivity or file connectivity. But here I am taking the connectivities. But these connectivities are opened inside the objects. Inside the objects, when we open any file, the programmer cannot close that file. Who will close that file when the file is opened inside the object is only garbage collector will do. But how it will close the files which are opened inside the object is using finalize method. That's why it will not destroy the object directly. Just before destroying the object, first the garbage collector will go to the this test class, because it is test class object, and it will verify for the overriding for the finalize method. If it is not there, it will execute the overridden method of the object class. If it is there in the overriding method is there in the test class, it will execute that method, and using that method, it will close the connections, database and file. After that, it will simply destroy the object, means it is releasing the memory allocated for this object. So with this, garbage collection is completed.